This video is on synthesis and decomposition reactions. If we think back to John Dalton's atomic theory, he stated that chemical reactions occur when atoms are separated, joined, rearranged. We're going to learn about two of those chemical reactions today. One's where our atoms separate, and one's where atoms join together. Type are synthesis reactions. Here, two elements combine to make a new element, so our atoms are joined. So if I have element A that reacts with element B, they're going to combine together to make compound AB. Now we can write these just like how we wrote our chemical formulas before. Magnesium plus oxygen are going to react together to make the ionic compound of magnesium oxide. Remember, they end in IDE. Now I can go ahead and write the formulas for my names. Magnesium, Mg, I checked to see is it a diatomic. No, it's not. Plus oxygen, that is a diatomic, so it's O2, reacts together to make magnesium oxide. Well, magnesium's in group 2, so it's plus 2. Oxide's in group 6, so it has a charge of -2. My charges cancel out, so I get MgO. Now I have to go back and balance. One magnesium here, one here, two oxygens, one oxygen. So I add in front. I go back and check. One magnesium, two magnesium, so two here. The next one is potassium with chlorine. They're going to react together to make the same kind of format as my magnesium oxide. So I have my metal first, potassium, with chlorine, my anion makes chloride. So potassium, element K, not a diatomic, so it's just like itself, with chlorine, that is a diatomic, so Cl2, makes potassium chloride. Potassium is +1, chloride is -1, so KCl. Now I balance. One potassium, two chlorines, one chloride, so I added 2 in front, which changes my potassium, so I added 2 in front of the potassium. Now decomposition reactions are just the opposite. It's a compound breaking down the elements that make it. So this is the separation part of John Dalton's atomic theory. So magnesium oxide, reverse of what we did before. Magnesium oxide breaks down into magnesium. And the second half, oxide, came from oxygen. I go ahead and write my formulas. Magnesium oxide, which is MgO, magnesium, Mg, plus oxygen, the diatomic, so O2. And I go ahead and balance 2 and 2. Same thing can be done with potassium chloride. Potassium chloride breaks down into potassium, chloride came from chlorine. Potassium chloride is written as KCl, breaks down into potassium and chlorine. Potassium's not a diatomic, but chlorine is, so Cl2. Then to balance, add a 2 and a 2. So remember, when we're writing these, when we're writing compounds, the nonmetal and a metal, when they're reacted together, they make that ionic compound of the metal nonmetal. Remember that a metal is positively charged, which is a cation, and a nonmetal takes on a negative charge and is an anion. Anions always come last, cations always come first for that ionic compound. Also remember that an anion, when it's an anion, it ends in IDE unless it's our polyatomic ion. Okay. Cations are always named as the metal name inside of an ionic compound.